Okay, so today we are talking about identifying pairs of lines and angles, section 3.1 out of the book. So starting off here with a few vocabulary words. The first one's one you may know, parallel lines. So that's whenever you have two lines that do not intersect, but they are coplanar. So if you look at the little diagram here, so you can see that lines M and N, they are coplanar, but they never intersect, so they are parallel. So whenever you're doing the symbol for parallel, let me switch over here. Okay, so whenever you're doing the symbol for parallel, if you were drawing these out yourself, get my little pencil here. So if you had two lines like this, and let me get a different color here. So if you want to symbolize that they are parallel, you can just make these little arrow thingies like this in the middle of the line. Sometimes they'll be closed off and colored in. Best I could do with my pencil here, or with my finger rather. So that would be a way that you can symbolize the parallel lines, and you can see how they're shown here on the page. Okay, so the next vocabulary word that we have is skew lines. So skew lines are two lines that do not intersect and are not coplanar. So again, if you look over here at the diagram, you can see line M here and line K here. They are not coplanar, they do not intersect, so they are skew lines. And then finally, we have parallel planes. This one should be pretty obvious here. So these are two planes that do not intersect. So again, if you look down at our diagram, you can see plane T here. This one's up nice above plane U. So those two are not going to intersect. So those are, again, parallel planes. Okay, and one last note here. So let me get my pen tool here. Okay, back to the brown. Okay, so we showed how to do our parallel lines here, just doing our markings. What we can also do is, like if you were trying to say that these are parallel, so if you wanted to say, like up here, lines M and N are parallel, all you do is just draw these two little vertical lines in the middle. So that's saying that M is parallel to N. Okay, so moving down our page here, we're going to do example 1. So the instructions here say, think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? So for question A, we're trying to find the lines parallel to CD and containing point A. So here's CD, here's point A, and we are trying to find the lines that are parallel and containing point A. So you can see there's actually three of our lines here that are parallel to CD, but only one of them that contains point A, and that obviously is right here. That's point AB. Okay, so for question B, we have lines skew to CD. So again, here's CD, and containing point A. So if you look at our illustration here, we have AG here. So that one's obviously never going to intersect with line CD, and that contains point A. And then also we have AH here, which is also skew. and also contains point A. So AG and AH would be the answer to that one. And again, AB would not be an answer to this one because it is parallel. Okay, for question C here, so we have lines perpendicular to CD and containing point A. So again, so we have our CD here. So we have CB, we have DA, we have CF, and we have DE that are all perpendicular to CD. However, the last part of the question again was and also containing point A. So the only one of those that we had that satisfy both criteria would be our line segment DA here. Okay, and for question D, we have planes parallel to plane EFG. Okay, so EFG is right down here and containing point A. So this one should be pretty obvious here. So it kind of looks like the bottom of the box down here. This is the top of the box, so that's going to be the parallel part. So we can just call this plane ABC. Well, I think this is a good time actually to just pause also and say, be careful on reading the instructions on these. So like this question says, which line or planes in the figure appear to fit the description? And as I've said, one thing you need to be super careful about in geometry class is they love to make things look like they are something, but they are not. So be careful to make sure that each question it explicitly tells you that yes, this is a right angle, yes, these lines are parallel. Make sure that you're checking all of that, because I try to think of geometry textbook writers as the most evil people in the world, and they just want to fool you as much as they can. So just try to make sure there. Just a little tip. Okay, so next we're talking about parallel and perpendicular lines in a plane here. So you can see with our little diagram here. So we have this line here, this given line, which is L, and we also have this, and this is L. We also have this point up here, P. Okay, and you can see what they're saying here. Is through a point not on a line, there are infinitely many lines. So we could have lines going here, here, here. It can go all different directions. So exactly one of these lines is parallel to the given line. So going through point P and parallel to this line L, we have this line right here, line N. And exactly one of them is perpendicular to the given line. So perpendicular making this 90-degree angle here. So line K would be the one that is perpendicular through point P to line L. And this brings us to our next two postulates. We have first the parallel postulate. So that one says if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. And that's exactly what we just did up here with showing the line N being parallel to the original line L. And then the perpendicular postulate, postulate 14, if there is a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. And again, that was our line K up in the illustration up here, parallel to line L. Okay, so let's go do example 2 here. Question is, the given line markings show how the roads are related to one another. This didn't come out the best on my photo, so I added some of the parallel marks here, and then we have our little 90-degree angle here, so we need that for our question. This should look a lot better in your book than it does on here, although it's not the easiest to see on there as well. So anyways, so for A, it says name a pair of parallel lines. So again, you're just looking for the little parallel symbol. The trap that they're trying to set here is that these two longer lines here kind of look like they might be parallel. They don't have the markings though, so that's the trap that they're trying to set. So just look for the markings. So we have our line MD here and our line FE here. Those are the ones where we have the parallel markings, so those are your parallel lines. Then the next question is name a pair of perpendicular lines. So again, what you're looking for perpendicular, you're looking for that little right angle symbol there. So we have the line MD again. We also have this line BF. So those two lines are running perpendicular. Again, all you're looking for is that right angle symbol. Don't fall in for any of the traps, which are all over this picture. And then question C, is line FE parallel to line AC? I honestly would have thought they would have tried one that would be a little trickier because it's pretty easy to see that line FE is not parallel to line AC. However, the reason that they're wanting you to use here is that MD is parallel to FE, which we already established, so MD and FE. And as we were saying by the parallel postulate, there's exactly one line parallel to line FE through M. So that's their explanation, but it's pretty obvious even just looking at it that those two lines are not parallel. Okay, so another new vocabulary word for you here, which is transversal. Transversal is just a line that intersects two or more coplanar lines at different points. So you can see examples of transversals. This is a transversal here, and this is a transversal here, and here, and here. Okay, so whenever we have angles created by the transversal cutting into these two lines, we have different situations then. So the first one here is corresponding angles. So what you're looking for corresponding angles is whenever you have, like, angle 2 is on the top right side of this line here, and angle 6 is also on the top right side, so they have corresponding positions there. So this angle here, which would have been angle 1, and angle 5, not shown, which is right here, that would also be corresponding, as with this angle, and this angle, and this angle, and this angle. Okay, so that's corresponding. Then we have alternate interior angles. Okay, so you can see the definition here. So if they lie between the two lines and on opposite sides of the transversal. So the example they have is angle 4 and angle 5. See how they're on opposite sides, but they're both inside here. So we also could have done this angle here and this angle here. Also would have been alternate interior angles. Okay, so let me move this up here. Okay, so we have next the alternate exterior angles. So very similar to alternate interior, where those, you know, the word interior, that means inside, and exterior, that means outside. So this one, we have angle 1 up here and angle 8 down here. We also have angle 2 here and angle 7. Again, not shown, but you can tell what they are. So again, they're on opposite sides of the transversal. This time they're on the outside. Finally, we have consecutive interior angles. So that's just the two angles that lie in between these two lines. So 3 and 5 here, 4 and 6 on this side also would have worked. Okay, so we're going to go ahead and do example 3 here. This illustration is very similar to what we just had. It's just turned on its side, basically. But you're just identifying the different types of angle relationships here. So the corresponding angles, if you look at this, again, you're looking for them to be in the same position. So angle 1 and angle 5 would be the first set. Here, let me get my little pointer here. Okay, so angle 1 and angle 5. See how they're on the same part of the line here. Then 2 and 6, 3 and 7, and 4 and 8. So again, those are all in the corresponding positions in relation to their lines. So for B, we have alternate interior. So again, those are on the inside and opposite sides of our transversal here. So that would be 2 and 7, and 5 and 4. Then for C, we have the alternate exterior angles. So again, opposite sides on the outside. So angle 1 and angle 8, angle 3 and angle 6. So those are our two sets of alternate exterior. And then we have the consecutive interior. Again, those are just on the same side and side. So angle 2 and angle 5 is a consecutive interior. Also angle 4 and angle 7.